All right, in this video, we're going to be going over our notes 8.1, which will be about similar right triangles, and we'll learn about something known as geometric mean. So to start, we want to go over our parts of a right triangle. Now, whenever we have a triangle and there's a right angle, that is how we define a right triangle. Now, across from the right angle, this side right here, side AB, this side is known as the hypotenuse. Now, the sides of your right triangle, the remaining sides, the one that's not the hypotenuse, we refer to these as the legs. So AC and CB are both considered legs for this right triangle. Right? So very important for this chapter that we understand where the hypotenuse is located. The hypotenuse is located across the 90-degree angle. Now, we are doing a little bit of review here before we actually jump into the notes, and we want to review something about solving similar triangles. Now, similar triangles was something that we covered in the last chapter, and we want to remember that in similar triangles, corresponding angles are congruent. So if we look at the picture here down below, you'll notice that the angles marked in blue are congruent, same with the angles in green and the angles in red, right? What we'll be making use of today is corresponding sides that are proportional. So this was whenever we looked at corresponding sides, we would match up those sides. For example, we would say this side C, let me actually highlight that here like this. This side C is the side connecting the blue and the green. So that corresponds to this side here, F. And then this side of A connects the green and the red, green and the red. So what we were doing in the past was we were looking at setting up some equations like, well, yellow over yellow, C over F, is equal to green over green, which would be A over D, right? And from there we would cross multiply, right? That's essentially what we're going to be doing today in the notes. Now, so that we understand the connection between geometric mean and what we end up doing, we want to talk about what is the geometric mean. Well, the geometric mean of two positive numbers, a and b, is the positive number x that satisfies the following. So essentially, you can think of geometric mean, if you want to remember something about this, geometric mean is going to be denoted by this formula right here, which is a over x is equal to x over b, right? And if you were to go through the process of cross multiplying here, well, x times x would give you x squared. And then a times b is ab. So in short, what we usually recommend is when you're looking at geometric mean, it's simply just this formula, x squared equals ab, right? But this is the origination from it, where we have this proportion. So let's look at an example of us finding geometric mean. Example number 1 says find the geometric mean of 4 and 12. Well, if we look at 4 and 12, we can represent this as a and b. Well, if our formula for geometric mean is x squared equals a times b, well, then we have x squared is equal to, well, a is 4 and b is 12. So if we were to multiply that, we end up with x squared is equal to 4 times 12, which is 48. And if we're solving for x, we would square root both sides. And from there, we would need to look at the square root of 48. Is that a perfect square, right? If you were to type that into the calculator, it's going to give you a long decimal. This means that we're going to have to simplify. So if we look at 48, we have to break this down to simplify. We can do 2 times 24, 2 is prime. 24 breaks down into 2 times 12. And then 12 is 2 and 6. And then here we have 2 and 3. So the way that this worked is we were looking for pairs of the same number. So for this pair of 2's, 1, 2 comes out. And then we have another pair of 2's. So another 2 comes out. And then what we have remaining under the square root is a 3. So in short, looking at the value of x, x is equal to 2 times 2, which is 4, and then we have our root 3. And so there we have it. When you're asked to find the geometric mean of two numbers, please understand that you are just using this formula right here, the x squared equals ab. Right? When you square root, if it's not a perfect square, the expectation is that you simplify. So let's go ahead and keep moving to the next part of the notes. The next part of the notes is talking about theorem 8.1. Now this is known as the right triangle similarity theorem. This says that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So in short, what this is saying is the following. If we have this right triangle ABD, right, the large one, whenever we draw in whenever we draw in an altitude, in this case AC is our altitude, when we draw in that altitude to the hypotenuse, what happens is that we create a total of 3 similar triangles, right? We have the large triangle ABD here, and then we have our two triangles here. So in total, we have 3, right? So the fact that we have 3 similar triangles allows us to write this statement here down below, which is known as a similarity statement. So let's look at where this similarity statement comes from and why these triangles are similar. So we're going to follow these 3 steps here. So what we're going to do is in the large triangle ABD, we're going to mark the acute angles D with 1 ring and angle B with 2 rings. So if we mark angle D with 1 ring and then angle B with 2 rings, we would have a picture that looks like this. Now, what we're going to do is we're going to separate out all 3 triangles. So if we separate out all 3 triangles, then we'll start with the large triangle first. Here's going to be the large triangle, which we'll have in black here. This is triangle A, B, D. And whenever we separate out these triangles, let's go ahead and mark the rings that we've already marked in the picture. Angle D had 1 ring, and angle B had 2 rings. Next, we're going to draw out the triangle in red. So here we have triangle now ACD, and our right angle is at angle C. And then again, we're going to look at, well, angle D is also part of the right triangle that's in red, so this has 1 ring. And then lastly, we have the blue triangle, which our blue triangle is going to look like this, with our right angle located here, and this is triangle ACB. And earlier we marked angle B with 2 rings, so we'll go ahead and do the same here. Now, we're going to go ahead and look at these 3 triangles and determine why are these triangles similar. What makes the black triangle similar to the red triangle? Well, if you look here, they both have the 90-degree angle that is congruent, and then they also have the single ring that's congruent. So these 2 triangles are similar by angle-angle similarity. Remember that we said we can prove 2 triangles similar by using angle-angle in the previous chapter. So we know that these 2 triangles now for sure are similar. Now, if we were to back this up and now look at the triangle in black with the triangle in blue, well, similar situation here. They both have a 90-degree angle, and these both have angle B marked with 2 rings. So 2 pairs of congruent angles means, again, we have angle-angle. So now we know that the black triangle is similar to the blue one, right? And one other thing that we mentioned in the beginning of the notes was this. We said that if 2 triangles are similar, then all of their corresponding angles are congruent. So the second that we've determined that the black and the red triangle are similar, that means that all the 3 angles have to be the same within both triangles. That means if in the black triangle I have a 90-degree angle, then I have to have one in the red triangle, which we do. If I have an angle with 1 ring, then I better have an angle with 1 ring here if these are similar. This leads us to imply here that angle A would have to be an angle marked with 2 rings, right? That would be the only way that these are similar for all of those angles to be congruent, right? And if you look at the blue triangle, this would mean that our missing angle here would be the one with 1 ring, right? So this is the situation that's created here where all of these are similar, right? So this leads us to how we write that similarity statement, right? If we were going to look at writing the similarity statement here, starting with the black triangle, if we call this triangle ABD, then look at how we started. We started with, if we're highlighting here, started with the yellow angle, the right angle, and then we moved to the blue angle, which is with 2 rings. So that would be similar to if we look at the red triangle. Our red triangle, if we start with the same order, and we might as well highlight and color code these all the same. Our 90 degree is with a yellow, and then our double ring angle is marked in blue. So if we were to look at writing our similarity statement here, following the same order, we have first the yellow angle, then the blue. So in the red triangle, this would be CA, and our last angle is D. So that leads us to finish the last triangle, which would be following the same order, yellow angle to blue, so CBA. And here is the way that we would write that similarity statement. So we use the rings here to help us write that similarity statement. So here we have triangle ABD is similar to triangle CAD, which is similar to triangle CBA, right? Which we see that statement match up with what we have here. We have the ABD in black, we have the CBA in blue, and then the CAD in red. We just have it in a slightly different order, okay? I guess let me clarify that. The order of the similarity statement is just switching the red triangle and the blue one, but they are written in the correct order. So that is how we write the similarity statement. Let's go ahead and jump into some examples now where you'll be looking at solving for missing side lengths. So if we look at this statement here, this part's important to understand that anytime an altitude is drawn to the hypotenuse of a right triangle, it produces three similar triangles. Now, here are the triangles that we're looking at. If we look here at the following triangles, we have the large triangle here, PSR, PQS, SQR. The example 2 here is asking you to solve for x, right? So whenever we're doing these types of problems, there is two methods on how to solve it. This video lesson is going to cover method number 1, which method number 1 is going to consist of us separating out all three triangles, right? Similarly to how we did on the last slide. Now, if we're following those same steps, what we want to start with first is in the large triangle, label angle P with 1 ring and then angle R with 2 rings. And then when we separate out our triangles, we're going to go ahead and label them as such. Angle P has 1 ring, angle R has 2 rings. Over here, angle P has 1 ring and angle R has 2 rings, right? So we're separating out all three triangles to start with, and we're going to identify where the right angles are located. In the large triangle PSR, the right angle is located at S. In the medium triangle, triangle PQS, here's PQS, our right angle is located at Q. And then the small triangle SQR, the right angle is going to be located here, where we have a right angle at Q. Now, what we're going to do next is we're going to label the side lengths. If we look at the large triangle first, we know that SR is X. That's what they want us to find. From P to R, they don't directly give us that, but they break it up into two pieces. So from P to R, 12 plus 2 gives us 14. So the entire length of that's 14. And PS, we don't know that for the big triangle. So we move on to the second triangle. The medium triangle, we know that from P to Q, this is 12. And then QS, we don't know. And PS, we don't know. So this is all we can label. And then the last triangle, SQR. QR, the bottom side is 2. And then SR is X. So here are our triangles. We know that these three triangles are similar. So we're going to solve this the same way that we solved it in the previous chapter. If we're going to start focusing on color coding our side lengths here, let's look at SR. This side length here is connecting the right angle with the double ring. So right angle to double ring. Well, one step that I forgot to mention here is that you're going to want to go ahead and fill in those missing angles there for the other triangles, right? So if we look at this triangle here, there is no double ring, but the double ring here is missing at S. And over here in this last triangle, we have the double ring. We're just missing the single ring, which means the single ring goes up here, right? So this should be something that we mark within kind of those first couple of steps. So we'll see that process done correctly or in the right order on the next example. But if we were to finish color coding here, our purple side here connects the right angle to double ring, right angle to double ring here, right angle to double ring. So what we're doing here is we're color coding our corresponding sides, right? So those are all matching. And you can understand that these are matching by, yes, the angles. And you can also look at this visually. This is the shorter leg, right? This leg of the triangle, the right triangle, is the shorter one between PS. Same thing here. This is the shorter leg. This is the shorter leg. Now, if we continue the color coding here, this side here represents the hypotenuse, right? Single ring to double ring, single ring to double ring, single ring to double ring. And then lastly, our last remaining side, PS, this represents the long leg, which is single ring to right angle, single ring to right angle, and then single ring to right angle. So now that we have this color coded and have all of our corresponding sides set up to where they're matching, we can focus our attention on solving for X. So if I want to solve for X, it's up to you how you decide to start your equation. I'm going to start with blue here. If we start with blue, then what I can do here is 14 over, well, blue over blue. Am I using the second triangle or the third triangle? Well, I don't know anything about blue in the second triangle, so I'm going to focus on using these two triangles here. If we look at blue over blue, we're looking at 14 over X. That's equal to, well, now I need another color here in this triangle. Purple is the only other side we know, so X over purple would be 2. So if we're looking at setting that up, how did we do that? We did blue over blue here. 14 over x is equal to purple over purple, which was purple over purple, x over 2. Right, so I'm taking the time here to stress the setup because setting up the equation is the hardest part here. But once you have it set up, then you can cross multiply and solve for x. Now, one way that you can find if you set this up correctly is if you see one of the diagonals repeat. So if I look at this diagonal here, I have x times x. That tells me, hey, I set this up correctly. So if we cross multiply, x times x is x squared. 14 times 2 is 28. If we square root both sides, 28 is not a perfect square. So we would be looking at x is equal to, and we have to simplify here. So 28 would be broken down into 2 times 14, 2 times 7, and there we have it. We have a pair of 2's here, so 1, 2 comes out, and under the square root, all we have left remaining is a 7. So our answer here is x is equal to 2 root 7. And this represents method number 1 on solving similar right triangles like this. Now we do this process whenever we have a right triangle with an altitude drawn to the hypotenuse. Where is my altitude? Remember, altitudes make 90 degrees with the opposite side. When I have an altitude drawn to the hypotenuse like this, we do this process here, separating out the 3 triangles. So let's practice that with another example. If we look at example number 3, it says find QS. Now, if we're going to find QS here, one thing that I suggest doing here to start is marking your right angles, right? So your right angles are there in the picture already marked. If they're not, go ahead and mark them. Next, go ahead and draw your rings. Remember what we said, let's mark angle P with 1 ring and then angle R with 2 rings. What we're going to do now is we're going to separate out all 3 triangles. You have the big triangle here, PQR. So let's draw that one out. So this will be triangle PQR. We have a right angle here. Let's separate out the next triangle. We have the next triangle here as this small one here, which will have a right angle here. This is triangle PSQ. Right, so PSQ is this triangle here. And then the last triangle that we have is the medium triangle here, which this will be triangle QSR. So we've separated out all 3 triangles, and then let's go ahead and go through the correct steps here. What we need to do is mark those angles that contain a ring. So angle P has 1 ring, angle R here has 2 rings. In the blue triangle, angle P has 1 ring. That means that the double ring here needs to be located at angle Q. In the red triangle, QSR, R is the one with 2 rings. So that means angle Q is the one with the 1 ring. Now, always start by separating out all the triangles and then marking all of your angles, right? The right angle and then the rings. From here, now we can go ahead and start to label. Now, if we start to label, looking at the large triangle here, do we know the length from P to R? Yes, they told us that that's 30. So this is 30. Do we know anything else here? We don't. Now, one thing that we do want to make sure that we're reading carefully, and this is my fault for not reading it, is, well, let's read what they want us to find. They want you to find QS. Do we currently know what QS is? No. When we don't know what something is in math and we want to find it, we typically call it X. So let's call that X. All right. So if we're going to continue labeling here, right, if we continue to look at the large triangle PQR, the only thing I know is the bottom side is 30 PR. I don't know anything about PQ, and I don't know anything about QR. So we move on to the next triangle, the blue triangle. Looking at the blue triangle, from P to S, we know that that length in the picture they tell us is 6. And then QS, well, that's what they want us to find, which we called that X, so we labeled that with an X. In the red triangle, very similarly here, QS is, we said, X. And then SR, they don't directly tell us what that is in the picture, but I can find out what SR is. If we do 30 minus 6, then that gives us 24. So I know this missing piece here is 24. And then we don't know QR, that's all we know. Okay. So once you've got all your triangles separated, your angles labeled, and all of your sides labeled, then we can go ahead and start to color code and set up our corresponding sides. So for color coding here, let's look at the first side we have. The first side we have here is single ring to right angle. We're going to do this in green. Single ring to right angle here is in green. single ring to right angle. So all of those are corresponding sides. Now let's look at the second side. This is right angle to double ring, right angle to double ring, right angle to double ring. And then lastly, we have the hypotenuse, which is single ring to double ring, single ring to double ring, single ring to double ring. So now everything's color coded here, and the question is asking us to find QS, which QS is X, right? Now, X isn't even present in this triangle, and I only know one side. So the two triangles that we're actually going to be using here are going to be these two right here. So all we have to do is set up our proportion on how we want to solve for X. Now, one way that we can do this is if we do green over green. If we do green over green, we're looking at 6 over X is equal to, if we do purple over purple, X over 24. And to check if we set this up correctly, check for your diagonal to repeat, and it does. And when you're checking this, sometimes it's the variable X that repeats, but sometimes it's a number that repeats. I could also just, looking at a different question, making different numbers up, I could also have a situation like this where we have something like this, right? This is the diagonal that repeats. That's okay. That happens sometimes. We just haven't seen that in the notes yet. But if we go back to the problem that we are looking at here, this diagonal repeats. If we're solving for X, we get X times X is X squared, and then 6 times 24. This gives us 144. From here, we square root both sides, and we see that for this one, thankfully, the square root of 144 is just 12. So we get X is equal to 12. Okay? So really, we're not doing anything crazy different than the previous chapter. Now we're just looking at these 3 triangles at a time, right? It's our job to identify which 2 triangles we're using, but the setup, the cross multiplication remains the same. So we'll finish up by looking at one last example here. Looking at example 4, it says find the value of X, Y, and Z. So if we're going to look at finding the value of X, Y, and Z, well, we need to go ahead and look at the large triangle. Large triangle we have is GHK. Mark your single ring, mark your double ring. So we're going to mark G with 1 ring, K with 2 rings, and then separate it out. Here is the large triangle. This is triangle GHK. Here's your right angle. Look at the second triangle. In this second triangle, we're looking at triangle GH. And then you're noticing that, hey, there's no letter here. So we're just going to make up our own letter there. We'll just call this J. So we'll call that GHJ. And then lastly, the blue triangle here would look like this. We'll call this J. This is where the right angle is, KH. So from here, we mark our rings. Angle G has 1 ring, K has 2 rings. In the red triangle, G has 1 ring. That means H will have 2 rings. And then in the blue triangle, K has 2 rings, and that means H will have 1 ring. So now we go ahead and start labeling our side lengths. If we look at the large triangle, let me actually do this in a different color so it's easier to read because we have a lot going on here. GH is Z, HK is Y, and then from G to K, well, G to K, this is 9 plus 3, which is 12. So this is 12. Looking at the red triangle, from G to J is 9. G to H is Z, and then H to K is Y. In the blue triangle, JH is X. Sorry, I mislabeled that last part, sorry. JH is right here, this is X. And then to the blue triangle, JH, again, we have here X. JK is 3, and then HK is Y. Right? So it can be very easy to make a mistake. You just saw me make a mistake. So when you're labeling your sides, just be careful. Now, let's go ahead and color code our side lengths here. If we're color coding our side lengths here, let's look at this first side here. GH, this is single ring to right angle, single ring to right angle, single ring to right angle. Looking at what we have next. HK, right angle to double ring, right angle to double ring, right angle to double ring. And then our hypotenuse, single ring to double ring, single to double, single to double. So now everything is matched up, color-coded. Now it's up to us. What do we want to find first? We want to find X, we want to find Y, or we want to find Z? I'm going to go in order here. We're going to find X first. So When I see x in this triangle, sorry, this one right here, and I also see x in this one, right? I'm looking for x in at least one of those triangles. So I'm going to actually be using the two triangles that we have here with an arrow. If we're going to solve for x here, one way that we can do this is we can do x over, I'm going to do purple over purple. So we're going to do x over 3, right? So here we just did purple over purple. And that's going to be equal to, well, I need another pair of sides in these two triangles to work with. I'm not going to choose the blue side because that's z, that's a different variable. It'll make it harder, so let's do green. If we do green over green, we're doing 9 over x. So there we have it. Now, to check our setup, cross multiply, see if you get a diagonal that repeats. You do. Here, this time the diagonal that repeats is this way. So if we cross multiply here, x times x is going to give us x squared. And then 3 times 9 is 27. Now, if we were to square root both sides, 27 is not a perfect square. If you were to go through the process of simplifying it, what you would end up with is 3 root 3. Right? And if you're not sure where we got the 3 root 3, go ahead and break down your 27, do your factor tree. This is where we're getting it from. You have a pair of 3's that cancels. That's 3 on the outside, 3 remaining. And so that's where we're getting the 3 root 3. Now, let's go ahead and focus our attention now on finding y. If I want to look for y, I don't see y in this middle triangle. So I'm going to look at this triangle here. I see y in purple. So I'm looking at purple over purple. Purple over purple, what I can work with here is this triangle and this triangle. If we do purple over purple, we're looking at y over 3 is equal to, well, in this triangle, I need another side to work with. Let's choose the 12. Blue over blue would be 12 over, in this triangle, y. Diagonal repeats, we're good here. So we get y times y is y squared. 3 times 12 is 36. If you square root both sides, we get y is equal to 6. Okay. And then lastly, we need to find z. If we want to find z, then let's look for a triangle that has z in it. Well, I see that z is in this triangle, and I also see z in this triangle. So that's probably our best bet here, looking at those two. So if we're going to start with this triangle, z is green. Let's do green over green. We'll do z over 9 here. That's equal to, now I need another side here. We can do blue over blue again. So 12 over z. And we cross multiply, and our diagonal repeats, so we've set it up correctly. Now if we do z times z, we get z squared. And then if we do 9 times 12, well, 9 times 12 gives us 108. If we square root, this gives us z is equal to, well, this will be 6 root 3. Right? If you're not sure where the 6 root 3 comes from, like I said, go ahead and break it down. Do what you need to do to see where that comes from. Just doing this really quickly. We get a pair of 2's that comes out, and then we get a pair of 3's that come out. So that is the 2 times 3 that gives us the 6, and then the square root of 3 remaining, right? But that is going to be the end of part 1 for our notes on 8.1. This is method number 1 for looking at similar right triangles. To summarize, you separate out all 3 triangles, draw in all your angles with your rings, label all your sides, and then color code in order for us to cross multiply. All right. If you have any questions or you found something confusing about this lesson, please make sure that you're reaching out to your teacher for help.